bolt through with a couple of these washers, you're not going to touch this plate. You're not going to short out this plate by making it touch. See, it clears perfectly. So I'm going to try to string them together, and I'll show you exactly what I did. So take your first plate and you put your nylon spacers through, or washers through, and then you get a couple spacers, throw them on there, and then you take your second plate and you put it on the other way. They're not touching. And then you put a couple more of these spacers on, and you put this plate on, and then have this. You thread that, thread a couple nuts on, Alright, now that that's all hunky-dory, actually I keep these a little loose so I can pass the screw through without having to, So, there's quite a bit of gap there, and if you just clamp these together like that, obviously it's going to short out because they're touching. So, that's why I have these. I use 3 of them, 3 washers. It's kind of tricky to get these in. You can use your imagination and patience, and it'll work perfectly. Like that. And there you go. That's one side done. So when you fasten down your bolt or whatever, and you pinch this as hard as you can, they won't touch. And then same goes for the other side. Since there's only one plate to the other side, you just simply pass the bolt straight through. And then once you get that done, tighten these back up. There's really not much to it. I mean, the hardest part is trying to get these holes matched up, because you need to hold the plates a certain way. And you're going to need a drill press and a bandsaw. There's some people who sell pre-cut slices already. K&S is one of those companies. I think if you go to your local hobby store, they have some. I'll post some links later. But that's pretty much it. And then the wires go on. So I mean, you can see the resemblance. That's about it. Just throw some wires on, put some bolts on it, and that's it. Like I said, this is important, adding baking soda is like changing the resistance between the plates. You're going to draw more amps if you add more baking soda, which isn't good because it's going to overheat the water. You want to put in, like I said, about half a teaspoon of baking soda, and that's going to draw approximately 20 amps if you use this. It might be a little bit more, it might be a little bit less. Also, you don't want to have any excess metal, meaning once you pass these bolts through and you put your connector on and you tighten your bolt down and everything, you're going to have, about an inch of thread left. You should cut that off with a grinder, because it's drawing more amperage, and you don't want that, because you want to keep it as cool as possible. That's about it. Thanks. This is it. After I changed it a bit, I decided to go with ABS plastic. This plastic has a higher temperature rating, and it doesn't transfer heat as easily. When this starts to heat up, it won't transfer heat. I had to do a little bit of modification. I guess, for some of you it would be considered heavily modified. I moved the battery back. I relocated the thing that holds the battery. I drove these 2 gigantic threaded rods into it. They're 5/8 in diameter, and then I have some PVC on it, and this thing just slides up and down on the 2 posts. And I'm going to cut these down, and I'm going to put some nuts on here, but this is pretty much how it works. See, if we come over here, let me open my car. I'm not going to turn it on now, but this is basically what my dash looks like. I got some switches over there, and if you had to look at this thing, you'd never think it was powered with hydrogen as well as fuel. But The switch that actually turns it off and on is this one right here. That's on when the little dot's on, and that's off. I had some of these rocker switches laying around, and that's why I decided to use. And this goes to the positive line. That's how I have it wired. So that turns it off and on. And I'm going to put maybe an amp meter or temperature meter up there in the right. And I also have some, room over here, so I might put, amp or temp or whatever. But just to keep an eye on it in case anything goes wrong. Go back outside the car. Take a looky. This is how I have it hooked up. There's a relay here that goes back to the switch, and there's a solenoid in the relay that lets the current pass through once I flick it off and on. But I won't talk so much about wiring it as I will how I have everything set up. This is the main tank, and it has water inside of it, and it has 3 stainless steel plates, 304 stainless steel, and there's a couple, there's 302, there's 303, 304, 306, and there's a couple others, I believe. But stainless steel is what you want, obviously, because it's going to be in water. You don't want it to corrode. And that goes into my moisture trap, which is pretty much just a tube. You can ignore this. This is a little thing that I tried to test out, but it basically goes into here, and if there's any water or spilling at all, it just gets stuck in here. And out comes the hydrogen and the oxygen, and the tube goes around here, and here I have this little T-fitting, and I have it teed right into the vacuum line right here into the intake manifold, and the throttle body is just before that. So here's where I had it last time, and I got 20% a 20% increase in that design, but I kind of slapped it together quick, and I wanted to do something a little better, a little bit more efficient. So it's airbox, mass airflow sensor, go through here, and here is the butterfly valve for my intake, and then the vacuum line is on the back side. Now I tried to go through the vacuum line for the brake assist, because it's vacuum brake assist like a lot of cars are, but it drew way too much vacuum. So I decided to go to the crankcase breather instead, and I installed a check valve onto this, so just in case there was too much pressure buildup, it wouldn't pump hydrogen back into the engine underneath the cylinders in the oil tank. So I finally did all the calculations and stuff for figuring out how much of an increase I got, and so on and so forth. So here it is. I used to get 22 miles per gallon on average, and now I get 25 miles per gallon on average. And this ranged from like 24 to 27. I just picked this number because this was the last number I used. It's actually a little bit more, but just for my sake, I want to use this just to see, kind of a baseline of where I am at. So I have a 13-gallon gas tank. So you want to calculate your mileage, and then you want to figure out how big your gas tank is, and then you want to multiply them out. This is 286 miles, and this is 325 miles. So 25 miles per gallon times 13 gallons, I can go 325 miles on the tank. With 22 at 13 gallons, I can go 286 miles on a tank. The difference between the two is 39 miles. So I travel 39 miles more with 25, miles per gallon at that. And then I take 39 and I divide it by 25, and I get 1.56, which is how many gallons I had saved. So about 1.5 gallons. And then I want to multiply that by how much a gallon is. Out here it's like 405, 415, 425, let's just say 4. Times that, I get 620, should I have it right here, 624. So that's what I saved by running that with that on after installing it. Like I said, it cost me a lot of money to build because I tried a whole bunch of different things. But if you nail this on your first try, it's going to cost you anywhere between, let's just say you know, just ballparking it, 50 to 80 bucks, depending on how small or big you want it, and depending on how badly you screw up if you do. But it's going to take you about 10 times to pay off approximately whatever. Just move the decimal over, so 6240. Let's just say that's how much it cost you to build the whole thing. When you drive it, when you fill up 10 times, it'll start paying for itself. That's about it. It's very easy to calculate. Yeah, just make sure you do everything correctly, and don't blow anything up or kill yourself.